anybody can benefit from that. Okay, so the learning target for today's lesson is 7.1 lesson. So you already have the package size, and it is proving trigonometric identities. My one question is, before I show this, is what is the meaning of identity? That's understanding is very important. Can you write this identity word? So identity. So basically, if I write x plus 3 equals 5, so this is an equation. Okay. So I'm having an equation x plus 3 equals 5. Can you tell me what is the question is this an identity? So how do we know something is an identity? Is it valid for every x? Is the left equal to right all the time or certain time? So if the only option for this is 2 plus 3 is 5, right? Do you agree? 2 plus 3 is 5. So there's only one answer. So this equation is valid. I'll say this is true valid only for x equals 2, correct? Agree? So this is an equation, but which is true only for one value. But if I write another one like this, what about x plus 3 the whole square, x squared plus 9x, 6x, and plus 9. This also is an equation. Why is this an equation? Because there is an equal sign. So equation means this has to be equal. But then is it an identity? So this is an equation, but is it an identity? So when do you think this is true? So, and you may be thinking, what is this? X plus 3 the whole square. Some of you will say, okay, x plus 3 the whole square means you multiply itself x plus 3. Do you agree? Yes or no? And if you use the distributive property, okay, x times x is x squared plus 3x, and use the FOIL method, you do all that and you get 9, and you see you eventually get this two combined. Do you see this two things combined to what? Plus 6x, agree? Yes or no? Correct? So that means you take the left side and work it out, do some work there, and you eventually get the right side. Correct, right? And that's why it doesn't matter what x is, it's always true. The left is always equal to 5. Doesn't matter what x is, does not matter what x is. So the left is always equal to the right. If you see the graph of this x plus 3, it is, if you try to put on the desmos.com, as I tell you to open your laptop and hey, put this, put that, you will always see, and you can see there's a plus 3 here, it means the graph shifts to the left. So if this is the original parabola, it goes 3 places to the right. Can you see that? It's like a shift to the left. Basically means, even if you put this one, even if you put that equation, you'll get this. Okay? And even if you put this equation, you'll get the same graph. Even they look different. Make sense? So that's what, so if we understand, we extend this idea to, okay, what is trigonometric identities? And you will see now that sine square theta, look at, plus, don't write, you already have it, right? If you see at the bottom, sine square theta plus cosine square theta is 1, and this is called Pythagorean identity. Did you see that? Always true. It's always going to be 1. So no matter what is, you can put pi by 6, pi by 6, pi by 4, pi by 4, then pi by 3, pi by 3, 0, 0. So always the answer ends up to be the same. Got it? So understanding of trigonometric identity. Now we go directly. There are two things happening. I want you to write here. Okay, can you copy this quickly? So there are two more ways to write this. Can you help me? What is another way to write? So even though sine square plus cosine square is 1, is there another way to write? Okay, Okay, I give you 30 seconds to copy this again. Write in your note. So sine square plus cosine square. Sometimes do you observe that here I wrote a parenthesis and I did not write a parenthesis, it doesn't matter. Okay? But some calculators, you remember the Inspire, the calculator, black calculator that we Inspire, you have to put parentheses. But when we are working on the hard paper, we don't have to take so much time to put those, all that. Just put finish. So my question to you is, sine square plus cosine square is 1, and then is there another 2 ways to write it? Okay, my question is like this to Jocelyn. Jocelyn knows that 2 plus 3 is 5. Agree, Jocelyn?
Yes.
Now the same expression can be write in another 2 different ways. What are the other options we have? 2 plus 3 is 5, right?
3 plus 2 is 5.
Oh, no. Okay, you are saying 3 plus 2 is also 5. But I want something like keeping one of this on the left.
5 minus 3 equals 2. That's what I was going to say.
Yeah, 5. We got it? So you just think of this first, okay? So 2 plus 3 is 5, so that's like alone. This is alone, right? A single by itself. And here you are combining 2 things. So you can also write this 2, okay? So the 2, keep the 2 as it is, and then what? Did you say 5?
5 minus 3.
5 minus 3. Agree? Now this is our number, so it becomes so easy to understand. But how do I write here? Now this is I said this is alone, right? This 1 is alone. So how do I extend this idea there? So this is the first and this is the second. You kept the first on the left, right? Can we write down? So what should I write here?
Could it be 1 minus?
Sine.
Yeah, I hear Hugo saying, isn't it?
Sine squared equals
So sine square theta equals
1 minus cos.
cosine square. Got it? So that's like, now why I'm taking this little time is, henceforth our mind should work so fast that, hey, if it is 1 minus cosine square, it is sine square. Either way. So both are same, okay? And another way to write is what?
Cosine square.
So you can it's like, this is one way to write, or you can also write this 3 is 5 minus 2. Can you see these 2 different ways? So just extending the numbers ideas in the trig ratios. So if I want to keep cosine square theta, that's 1 minus the other one. So the trick is always remember that if it is cosine, the other side is sine is subtracted from 1. Does that make sense? This side? So far so good? So this is the most important for this 7.1 lesson. It is just knowing this, we can do a lot of stuff there. And one more thing is, so there is another trigonometric Pythagorean identity is 1 plus tan square theta. Can you write down this? Equals secant square theta. So tan and secant go together. And remember that tan and secant, they always complement because they have the same domain. If you remember the domain of tangent, and this is, you can take any angles for this. Theta should not be 2n plus 1 pi by 2. This means you can't have multiple of pi by 2. You can see the tangent is right there, and you can see the secant is right here. Both have vertical asymptote at pi by 2. You can't have multiple of pi by 2. I don't want to break your head here, just go directly. So this is another one. And the 2 ways to write, and if you see in the videos that I posted, I already showed why it is and how it is. So now I don't want to spend time. 1 plus tan square is always secant square theta. And another two different way to write is, you can also write this. Somebody help me how to write another two different ways. One plus 4 is 5, agree? So if I write, there are two ways to write. One is keep 4 as it is. This 4 as it is. Can I write 5 minus 1? Now I'll keep 1 as it. Can I write 5 minus 4? Can I write? So I'm gonna use this idea over here. I'll keep this tan square as it is. So tan square theta equal this secant square theta minus 1. And this 1 equals like how I showed this 1 equals this secant square theta, the right side, minus tan square theta. So these are two more formulas. Is that okay? So far so good? And let's go directly to the problem now, okay? So once we know these things, the trick is, remember this, the trick is sine square and cosine square is 1. These are the two ones you should remember. If you forget this, at least we should know this too. So once you get this two, then you can always think, some of you may say, oh, I don't want to remember that, that's so difficult for it. That's so difficult to remember. Okay, at least you remember the left side. And then you can adjust, oh, that's how I get those things. Okay? Okay. So I'm taking a little time to grasp, all of you to really grasp this concept, okay? And one more thing is, remember, reciprocal is cosecant and is always 1 over sine. Just flip it. Secant is 1 over cosine. Those are because of the definitions. And I did not write cotangent, which is 1 over 10 also. It's not needed there. So I use, these are the most important. These are called even odd identities. Whenever there's a minus for sine, you can pull it out. Even for 10, you can pull it out. But for the cosine, it goes away. So that also is shown, I shared with you the video I made. Now these are what you deal is like cofunction identities. If you have sine pi by 2 minus theta is cosine theta directly, that is because of the geometry what we did long back. And these are right now what I'm doing. I think I missed this. So the last one is, if it is 1 plus cot square theta is cosecant square theta. And the two answers are the same way how you write this. So this is how I remember. When I was a student, I would say, oh, let me remember this one. And then I say, okay, I'll keep cot square as it is. So if I keep cot square as it is, and then this will be cosecant square. Then you take away 1, you subtract 1, it goes the other side and get 1. So it's so simple to remember. So keep this and then the rest. The second time I keep this one exactly the same, and I use this cosecant square theta, and you subtract the other one. So this is how you remember this, the second set. So 1, 2, 3, right here, can you see? 1, 2, so same thing. Okay, let's do directly now the problems. So how do we apply this in proving? So there are hundreds of problems here, and this your set has got only 15. We will have more just to get, because these are so important in the later class. When you do calculus class, suddenly you come across something called integral 1 over. I can just make my own sine of x and 1 minus cosine x, something like this. Okay, so lot of calculus 1, 2, 3, this trigonometric is used all the time. So let's do the first one. Can you try the first one? Let's see how far you can do. Where you get stuck up. Where you get stuck up. The first one. Okay. First problem of the day. Who gets $1 for the first one? First one is, so it says write down the trigonometric expression in terms of sine and cosine. So you don't have to do much work. You are given cosecant times tangent of theta. Anybody would like to help me? Quickly, Valerie?
You can write cosecant as 1 over sine theta.
Absolutely correct. I'm going to use the orange color. See this part? So this I'm going to replace 1 over sine of theta. Is that correct? Now that theta is just an angle. Remember, okay. Jasmine, you agree with this? So Valerie says, just replace cosecant and you can use. So the reason is you are using the reciprocal identity right here and say, hey, Mr. Bello, it's right there, cosecant is 1 over sine. Remember, this is the first class on just using this. I just wanted to get everything. Okay, becoming little more and more complicated in the next Monday, Tuesday. So let's really get this part right. But what about 10? How do I write 10? Remember, it doesn't show you. But what is what's that?
Sine over cos.
Yes. The definition, if you remember, the definition of tan theta was y over x. Remember, y means, remember y is the sine, and what is x is the cosine. You see that? So that's it in case you forget. Don't be robotic. Tan is sine over cos. Will you remember this? So in place of tan, what are you replacing by? Sine over cosine. Is that okay? So just get that part right. Oh, this is nothing. So I'm going to repeat it here. Tangent is, this is not reciprocal, like this is the definition. This is a identity also because even though it is y over x, and then you think that, oh, it's sine theta over cosine theta, that's it. And the same thing works for cotangent theta is cosine goes up and sine goes down. Nobody's saying yes. Got it? If it is cot, you just do the half. That's because definition of when you talk about cotangent, it is defined as x over y. Instead of y over x, it is x over y like that. And then you see, hey, x is always cosine, y is always sine, and that's how you get that. So get the concept right. But eventually we'll always remember, hey, I don't want to remember this definition, just tell me tan is sine over cos. You said it, correct? That's how you should be remembering, without thinking. Slip of it, just. Now anything else we can do, how do we simplify? I'll just give an example. If I have 1 over 3 times 3 over 5, what is the answer?
3 over 15. Oh no, 1 over 5.
1 over 5, agree? So basically what we say is, hey, this is up and down, right? Which is 3 over 3, and we know 3 over 3 is 1, correct? So this answer, what you do is just, hey, just cross out. It's like gets 1. So it reduces to 1. What stays is 1 over 5. Agree? Why did I show this?
Because it's figured.
That's what we have. You see this, there is that sine theta, which is the same thing. So it may not look like what is that called, like a number, but it's the same thing, right? So if it is the same thing, done. Is that okay? Like exactly something like that. Nobody's saying yes.
Yes.
Of course, you have to be sure also that theta, not always, because see, when it says cosecant, the angle cannot be 0. You know why? Because sine 0 is 0. So it's like you avoid multiple of pi's. But now I don't want you to think too much of that domain and the range. Just think, oh, that's all I do, and you get 1 over cosine, and you're done. Is that okay? Question, did you understand this simple first problem for the day? Hugo, 100%?
Yeah.
I don't want you to think, Mr. Bella, how can you just cross that? It's not a number, how can you cross? You may ask that. But remember, it is the value actually. Okay? That's the number, even though you don't see it like a number. It is a number.
Would it be sec over theta?
Which one?
I mean sec and theta, because 1 over.
But the question says, it says write this expression. At the end, the answer should be only sine and cos. Got it? But they could have asked the same question and say, I can reframe this question, prove that. I can make a problem myself, create a problem. Hey, can you prove that this whole thing becomes secant theta? And that's what Hugo is thinking, right? Because basically what is 1 over cosine is from the chart secant. So if there was a question like this, then you would write, oh, secant, which is the right. So you start with the left, this is the left, and this is the, agree? Should we go to the next one?
So it's just 1 over cosine.
You 1 over cosine, because the question is like that. He says, just write anything that you get where go reduce to the lowest form and then sine and cos. Quick, I have to do a lot of problems. Huh?
1 over cosine is sec.
Secant, yeah.
Yeah.
Here.
Yeah, so
I was just now explaining.
yeah.
Always this dang. This 1 over cosine. Did you read the question there? See, you don't read the question, and that's the problem. What does the question say? Can you, Jasmine, read that?
Write the trigonometric
Trigonometric.
expression in terms of sine and cosine and then simplify.
It means keep sine and cos as it is.
And simplify.
Simplify, that's how we cancel, right?
Yeah.
That's simplify.
Okay.
What is simplify basically means is you just reduce to the low. See, if I have like this, right? And simplify, what is simplify means? Don't keep this. Can you reduce it? Can you make it more smaller? That's all it is. So we say, hey, 2 divides 4, and 2 divides 6. That's the answer, which is called simplify. Okay, let's do the second problem for the day. Remember, we'll continue this on Monday more, but today I really want you to get. This one is cot square minus cosecant square x. Okay. Just to avoid confusion, I would like to also give a little fundamentals, make sure you know that. When I write like this, watch this. If I write sine square theta, what is the meaning of this? Remember, this is, what does this 2 basically means? You are multiplying sine theta twice. Did you get this part clear? So instead of writing sine theta, the mathematician felt, hey, that's too much of work to write. Look at this is too big. You have to write this 2 up, right? So what they said, okay, let's take this off and put it right here. Got it? So basically it's the same thing. Now, in this case it says cot square. First of all, first step is, can we write in terms of sine and cos? So let's go. What is cot means? Even though I don't have it over there, cosine over? Is that okay? Can we replace at least? So remember, if this is cotangent is cosine, let me nicely read it. Cosine over sine, it means I can write cotangent square, both has to be square, agree? So this cosine will be small to up here, and again sine small to up here. Is that okay? So what we replace cot square of x. So can we replace it there? Messiah, can you help me quickly? What should I write here?
Cosine squared theta.
Only thing, instead of instead of theta, what variable did they use here? X. So that's the only change. Minus, correct? And cosecant square. What is cosecant reciprocal identities? 1 over
Sine.
sine. So if it is square, what happens? So cosecant is 1 over sine, right? So that means if I square this, what should I square here also?
Sine.
Is that okay? You go, got it? So get used to, let's get used to this. I know sometimes this is too much, but get the only thing I forgot to write here. So this is because of Pythagorean identity, no sorry, it's a reciprocal identity. So if you square, I just want to show one more thing is, so if this is square, this basically same thing is sine of theta, the whole square. So we avoid writing this. That means sometimes it is cube, then it is cube. If it is sine of cube theta, this will be sine theta, the whole cube. Got it? That's all that means. So in this example, so I'm going to replace cosecant square of x as 1. I think I missed something here. What did I miss here? Divide by? Yeah, and I think I got carried away because I feel hungry at this time. At the bites. And when I eating my food, Jocelyn didn't like. She said, "Oh, Baba, you eating food?" And then so 1 over sorry. Yeah, sine square. So far so good? Nobody saying yes? 100%. Now what do we do next? Now if you get confused with this, I always like to show simple arithmetic. If I have 2 over 3 minus 1 over 3, how do we do this?
So 1 over 3.
Say it again.
1 over 3.
1 over 3. How? Okay, let me change this to 5. Jocelyn, can you help me? What is the answer for this? Do you have the same denominator? Yes, right?
Yes.
So if you have the same denominator, you just write it once, correct? And you subtract 5 minus 1, agree? Can we extend this idea right here? Do you have the same denominator both left and right? You know, as we progress, sometimes these two will not be there. And this will be square, and that is just, so you want to make the same denominator kind of thing. And I'm going to show you that very soon. Just imagine if this was not, if this was 6 and that was 3, what do you do next is?
Find the common denominator.
You want to have the same least common denominator, right? So that means you, in order to get 6, you have to multiply 2 and 2, agree? That's what we are going to do here. Okay? So sometimes this is square and this is not square, it's just a so right now it seems to be very simple, so the denominator stays the same, sine square theta. Oh. Okay. And then you write the numerator as it is, like how, remember the one that I gave an example, if it was like this. So what we write is, you keep the 3 as it is and you subtract the numerators, agree? So the numerator here is cosine square x minus 1. Anybody would like to, can we simplify this further? What is the identity, Pythagorean identity? Can we use this here?
It would be sine 2 over 2.
Now, the top one has a cosine square minus 1, right? Look at this, this is the main one. So, can we write this as, I think I forgot to write this. So, I think I wrote, right? So if I write 1 minus, if I keep cosine square, what is the answer?
1 minus sine.
And if it is sine square, then it is 1 minus?
Cosine.
But the problem with this one is this is first and this is second. So how do we do that?
Just flip it.
Yeah, flip it, but then you have to be careful. Can we simply flip? Can I simply write 5 minus 3 is the same as 3 minus 5? So what is that? Some change has to be done, what?
It should be able to multiply by a negative.
Yes, so this, if you write this way, it is wrong, right? Because this answer is 2, and this answer is negative 2, right? So this is not the same thing. So the only best option you put in the bracket, now it will be correct. So when you flip, you have to put a minus outside. Am I making sense now? So the trick is, if I want to flip this, what I do? I can flip this, keep the denominator as it is, and we will flip this. But when you flip this, what I have to do is, let me put a parenthesis like this. See? So what goes outside? Correct? So the trick is like this. So then the question arises, why did we flip, why did we swap this, or why did we change the order? Because now you know, hey, I know this answer. What is 1 minus cosine square from the formula?
Sine squared.
Sine square, actually. And the denominator stays the same. And then you notice that, observe, the top down is the same thing. You get negative 1, see? So beautiful. Got it? Listen to me. Today is just a kind of warm up. What is this called? We are warming up now, slowly. Just getting an idea. Oh, that's how I do. Oh, that's what reciprocal. That's that's kind of. But Monday we'll do the hard ones. So we'll post this video for Bianca and Nathalie so that you can check at home, right? And you can also see. I always upload it to YouTube. You can just. Did you see that tan inverse function that I did? How many of you saw? You saw? You good? No, you did not see, right? The one which says arc 10x function. So y is y equals tan inverse of x. How this works?
Oh, the video?
Yeah, the video I posted yesterday. I'm showing why the graph is like that, and one of the math teacher appreciated me. He was like, wow, I did not even realize like that. In little intricacies I show the kind of why and how. Because most of the time we just remember, oh, my teacher told me the graph of the tan or something like that. That's it. I don't want to know why and how. I'm showing in the video why it is like that, how it works. Tan, everybody, we know the tangent, right? That's the tan. Can you see that tan? But the inverse, undo, that's the one. Okay, let's move on to the next question. Can you try the next question yourself? Think over it. Just try. What is that? You're not losing anything, right? Just try the second one, third one. Okay, here it says verify the identity. What it means is, can you 100% make them, do you agree with? So let's see, it is tan of y, and this is cosecant of y. Is this really equal to 1 over cosine y? E minus 1 over secant y. Now we are lost, right? Anything strikes you. So the question is, can we get from, so there are two ways, there's a lot of different strategies students use to figure out whether the left part is really equal to the right. Right now, we don't know, right? If you see, whenever there is a minus and plus, remember this is a strategy I want to share. If there are two things of trig like that, always start that one. Get it? So, or of course, you can do both ways also. Or you can also start with the left side. Start with the left. So on your paper right now, we'll start with this is the left, right? Call this as left and call this as right. Okay? We'll begin with the left and see we get, so sometimes it may not be possible directly to get from left to right, but let's see, at least we can work out, simplify. Let's simplify this. What can we do about this, the left side? Misail, can you tell me? So I'll begin with the left. So I'll start with left. Anything else you can think of? 10. What does 10 mean in terms of sine and cosine? Sine over cos. That's all we can do. So the best thing is always do that. Change to sine cos. Okay. So these problems are more in changing. So I'll put a big division line, and there's going to be another small division line. Okay. So this is replaced by sine y over. Let me not use this. Too much of parentheses. I want to avoid this. Let's write just sine tan y cosecant y. I think your paper does not have parentheses. Do you have a parenthesis, Jocelyn?
We do.
You have? Okay. So then that's fine. So I'm not going to. That's too much of work. I just write this tan is sine over cosine. Is that okay? Now I use the color now. This cosecant. Now look at this color. Instead of cosecant, what do I replace by? Nobody's telling me. Is that okay? And now comes keep change flip. Do you remember what? Is this well for us?
Yeah.
Okay. So anyway, don't worry. I want you to try this. See how many of you can do, and we will continue this on Monday. Okay? Make sense? Can you put it up? Oh, your hand doesn't live there? Just put it up.